So for today's assignment and for the next test, you do not get to choose the method. It will be given in the problem. For your projects that I'm thinking about having you do, you get to choose your method. It's a project, so you get to choose. So that one, I haven't yet decided 100%, but if we have a project-based final, we still have to take a test on the material we cover after test 2. So it would only be the cumulative part of the final would be a project. So we don't have to relearn, well, we do have to relearn chapters 1 through 10. It's just a project instead of being on the test, whereas chapters like 11, 12, and 13 will be a mini test as opposed to a full test. It'll be both. It'll consist of a project. Again, this is all under construction because I haven't made the final conclusion. Everyone has to do really well on test 2. There has to be an improvement overall. So the average on test 1 was 79%. So if the average on test 2 is 80% or higher, then we can have a project-based fund. And then that'll consist of, the project will consist of a take-home project and then a presentation to the class. Like a 5-minute presentation class. Okay, I'll talk more about it as we get closer because, oh yeah.
The equation for like critical value stuff, will that be on the formula?
Yes. Okay, so let's talk about the p-value approach. The p-value approach uses probability instead of z-scores to make conclusions. We're going to be using, I'm in the wrong notes, I just realized. I need to be in 9.2b, which is this one. No, I need this one here. Oh wait, this is 1.9. My bad. Here we go. 9.2b. Okay, so we're going to look at the probability of obtaining these sample means here, or more extreme sample means. So what do we mean by more extreme? I'm going to do the first one for you. Do you see how these 4 graphs each correspond to the 4 sample means we have? Let's look at these 4 graphs. What does the first sample mean? Or what does the first graph correspond to? 15. Why do you think I put a little bar here? Because that's the first sample mean is 15. The second one is 18.5, so that's why I put a little bar here at 18.5. So we're going to now calculate the probability of obtaining this sample mean or a more extreme sample mean. I'm going to do this one actually, is a little bit easier. How many standard deviations from the mean is 18.5? 1. Very good. So 1 standard deviation below the mean would be good, 11.5, which would be over here. Within 1 standard deviation lies what percent of the data? 68. So we have 68% in the middle, and how much percent do we have on the sides? Does anyone remember? 16. Yeah, so we're going to have 16% here and 16% over here on this side here. So the probability of getting this sample mean, which is 18.5, or a more extreme sample mean would be what? Where are the extreme values? Are they in the middle of the 68%? No, on the outside. So what's the probability of getting 18.5 or more extreme? Well, more extreme could also mean, we're talking about two-tailed here. So we're talking about two-tailed. So it'd be 32%. Very good. So we're doing all these for two-tailed. So the first one would be 32%. So actually, this box here is 32%. Let's see if we can do it for these other 3 over here, using the empirical rule and two-tailed tests. So groups of 2, let's do a think pair share, so we're gonna try to do it on our own first, and then we're gonna just discuss as a group. That's why I didn't start with that one.
So wait, we're doing.
Let's do it for 15, for 8, and also 25.5. It's 95. 99.7. I'm gonna try to do these two first before we get there. David, let's have you work with Ava for today. Audrey, I feel like you're fine working by yourself.
Always.
Yeah.
So this is like one standard deviation. So we start at 15 and the standard deviation is 5, so that's like.
Right,
So
okay.
now we go in the opposite direction. So about 0.5.
So this one's Tuesday. Okay, yeah.
And then, so that's why this area right here between these two is one standard deviation and like
Two more.
it's just about data within one standard deviation, which is only 68%. So then we just two standards. It's 60.
Right.
So
Yeah, so everything in the middle.
5 times 2 is 7. So 7, 15, 22. And then so 7 back.
Within 2.
And if you're two standard deviations, then it's 9, this whole area is 95%, which is 5% left. So you divide that by 2.
So an extreme value is 85. Okay.
So try this bottom one, is 3 standard deviations. And then with 3 standard deviations, the area is 99.
And then 25.5. That, okay, so it would be like 5. It's like 3 for the mean. Would that be the
4.5.
Oh, 25.5 is 3.
The area is kind of the 7 point of the areas.
So it'd be like 0.3 divided by 2. 8 minus 3.
And then you just basically add those together, so 16 plus 16.
32.
32, and then so that's 8.5 is 2.5.
Just a 0.0.
Just 5. Yeah. The last
Zero
one.
point zero.
Oh, wait, no, it's point. 99.7%.
I think at 15 though. And then an extreme value would be 0.
In the chunk about the
Oh, we haven't done it yet?
If you're at 15,
chart.
like how
And
many
then
standard
x equals 15. I don't know how
deviations
this is because it's not clear.
Exactly. So that means that this whole area is extreme. So
It's 0, so you have It's
Yeah, so it's like,
No, that's what I was asking.
yeah, there's no like window, it's just the whole area.
0% on the side, or 0% in the middle, 100% on the
I
side.
don't know, I was getting like ready to do that.
So that'd be 100. The further away it is from the middle, the lower it
You
gets.
probably, yeah. You just printed it.
Yeah, so we're on this one, we're gonna have 50% on that side and 50% on that side.
You know how much is
Standard deviations.
which is about confusing. I haven't gone to that party up there all this stuff.
Okay, well, I'm gonna go ahead and share this. Okay, it looks like we're doing really well. So the probability of getting 18.5 was, there's basically a 32% chance of getting a number like 18.5. Let's talk about getting a number like 8, though. 8 falls how many standard deviations away? The standard deviation is 3.5. How many standard deviations below is 8? 2. So it's 1 standard deviation below is 11.5. Another standard deviation below is 8. So this is 2 standard deviations. So within 2 standard deviations is what percent of the data? 95. Where's the value that's 2 standard deviations above? So 8 would be 2 standard deviations below, and 2 standard deviations above would be 22. So I have 95% of the values between 8 and 22, and what percent of the data is on the sides? Well, you have 2.5% here, and you have 2.5% here, so what's the total percent of getting a value outside of 95%? 5%. So the probability of getting 8 or more extreme would be 5%. Okay, questions on how I got that value? So basically, what's happening to the probabilities as I get further from the middle? They're getting lower. Good. Let's do 25.5. 25.5 is how many standard deviations above? 3. I picked nice numbers. So 3 standard deviations below would be 4.5, and we have 99.7% in the middle, and what percent on the sides? You don't have to split it in 2 anymore. If we have 99.7% on the sides, it's good. We have 0.3% on the sides. So getting 25.5 or more extreme, what's the probability of getting 25.5 or more extreme? 0.3%. Okay. What about 15? Let's think about this logically. What's the probability of getting 15 or more extreme?
I think it's 0.03. So, oh, it's as a percent, not as a, okay, sorry.
I wrote these as percentages, but I could have written them as decimals. Like this would have been 0.32. This one would have been 0.05, and this one would have been 0.003. Okay, lastly, all values are 15 or more extreme. That covers the whole graph. Everything is either 15 or more extreme. Think of something that's not 15 or more extreme? No. So what's the probability of getting 15 or more extreme? 100%. So, also that's 1. Which of these sample means seems very unlikely? The first 2 seem very unlikely. No, first of all, like 100% are 15 or more extreme. 32% are values like 18.5 are how do let me rephrase this. The probability of getting a value like 18.5 or more extreme is 32%. That's pretty high. But once we start to look at 5% and 0.3%, these values seem to be not as likely to occur because they're on the sides. Okay, now let's go ahead and answer 13. A sample mean with low probability is blank extreme. So let's look at this chart. A sample mean with blank probability is more extreme. Think, pair, share. What do you think that missing word is? Oh, a sample mean with low probability is blank extreme. Okay. Think, pair, share. If you want to take some information from what I said earlier, go for it. Okay, what's the word that goes to the box? More. Good. So now we have a way to figure out whether we should reject, and that's to look at this probability. So are we going to reject when we have a small probability or a big probability? Small. Small means more extreme, more likely to reject. Small means more extreme, more likely to reject. So let's use that information for 14 here. Let's see if we can construct a null and alternative hypothesis and to decide whether we're going to reject it or not. Okay, groups of two, think, pair, share. This may be the same one as last time, so make sure to write the correct value for the null and alternative hypothesis.
Were we using 8 or 15?
We always put the population mean in the null hypothesis. That was a trick. You always put the population mean in the null hypothesis. The population mean is 15. That was a trick to see if you remember that, which value of the sample.
So the same thing is these. If you look at these,
It's a 5%.
so the low is above the population value, that's an extreme value, the more likely
8 is the standard.
So we say we should reject because the probability.
Again, the population mean is 15. That needs to go in.
Extreme values.
Okay.
That's the
How do we
sample.
know this population mean is? Oh.
It's over here. Mean of X bar. Coming. Okay, so 8. What was the probability of getting in? I think it was 5%. What's the probability?
Don't you think we'll do calculations here?
We kind of already did that. What was the 8 is the sample mean? What's the probability of getting a sample?
5%.
Exactly.
Oh, so you do reject.
Well, at this point, it's our opinion, but 5% seems pretty low to me, so I would probably reject it.
So see how like as these get lower,
Now we're just
those values get more extreme.
So the sample mean.
If you have an extreme value, do you reject it? So in this problem, the sample mean is 8. So we're looking at this probability. Is that the low probability of 5%? So then with a low probability means more extreme. So if you have a more extreme value, does that mean you reject or you don't reject? Yeah, you reject. Because it's extreme.
What was this? Please.
If you do like high your safety or whatever,
Oh, okay. So no
change
change.
value, the chance of the value.
So we're on 14?
Mm-hmm.
if the probability was high, it's much bigger, which means the chances of getting true value would be low. So then we can now 15. This is the value.
What, oh, 15, we're still going, I thought this was right.
Okay, the probability of getting a sample mean like 8, and I'll put in parentheses, or more extreme, is what? 5%. So what does that mean? Does anyone want to share? Yeah, so, okay, you guys, this is important. We're going to be doing p-value approach a lot. When mathematicians do hypothesis tests, most of the time they run the data through the computer just using the p-value. Plus projects, if we do projects, you need an interpretation of p-value. So, the probability of getting a sample mean like 8 or more extreme is 5%. That is low. Which is low. So what are we going to do? Since that was a very low probability of getting a sample mean like 8, we will do reject. It's basically more extreme. The lower the probability, the more extreme. I'm going to reject. So I'm rejecting. I'm not rejecting any people, so don't have to worry.
Give terms of it like that. What do you remember actually? Like if someone's like really extreme, just kind of like really out there, you gotta reject it.
That's such a good example.
I mean, maybe not like this age, but like when we get older.
Yeah, people tend to actually get, I think, less tolerant. Well, I don't know actually. That's now I'm sounding political. I can't. Or what? Do I want? I'm talking about my drama right now. Okay, we're going to talk about p-values now. We're going to officially calculate p-values. Now, let's start with the one where we just did with -2. Now, we already know when you have a z-score of -2, we already know what the p-value is. What is it? 95% within 2, so what do you have on the sides? 5%. So we should get 5% for the p-value. Now, let's officially calculate this. So the -2 goes over here, and then the +2 goes over here. How do we officially get the p-value? How do we find these areas using Excel? Norm.s.dist of the z-value, which is -2, true. That should give you half of the p-value because you have it on both sides. It should give you 2.5%. Okay, let's go ahead and make sure that we can do this on Excel. So go ahead and calculate the p-value using norm.s.dist.
Is it this or is it that? Can we use it? hit 0.275.
That's just this. Yeah,
It's on the book right
they're
there.
areas. Areas are always constant. Percentages are always constant. But we just right now, how do we find that?
You can download the one that was used to use for all the classes.
But we want the right area.
0.02.
Oh, you got it. What'd you do?
Yeah, I just like took out the true result.
Are you on?
For that, I got 0.3.
It's already half of the area.
Yeah, that's only half. That's only.
Oh, you doubled it?
We should get a value close to 2.5%.
Times 2.
That's how we know. Because if there's 95% in the middle, there's 2.5%. We should just say we wanted it as a percentage. Yes? You might be using a different version.
Are you using Google Sheets? Just get rid of it. Does that work?
So I'm going to start typing in equals norm dot s dist of 2 comma true, or negative 2 comma true. That's 0.02275. How do I find the right area? Do I want to do norm dot s dot dist of 2 comma true? Is that going to give me the answer? Good, that's going to give me the right area. So if I do type it in with equals norm dot s dist of 2 comma true, I get a huge number like 0.97725. I have to do 1 minus that in order to get this the 0.02275, which will give me that right area. So 1 minus norm dot s dot dist of 2 comma true is 0.02275. So what's the answer? What's the answer? Is it 0.02275?
Do 1 minus that.
Why do we find two different values? What are we doing with those two values?
0.9.
We're adding them together, just like over here. We had 2.5% on the left, and we had 2.5% on the right. We took those two, and we added them together to get 5%. Same thing here. You have to add them together. So your p-value is 0.02275 plus 0.02275, and that is going to be equals this plus this 0.0455. That's the final answer. Yeah, I mean, like, this is the same example that we just did. We're just doing it with Excel now, so it's 5%.
Wait, but he just added points or just added the same thing.
Yeah, I know, it's gonna be the same thing. Oh. Same area.
Some of you are noticing, do you really have to do both of these?
I just did norm s. I didn't do 1 minus.
For the right.
Okay, that's true. That's
For
very
just
true.
two,
It's not
and two,
symmetrical.
you do 1 minus.
You have
Does that
to
come out to a
do them
different
separately,
value?
Because
Because we're using normal distribution, we could have just done one of them and then done what with it? Multiplied it by 2. I
Oh, so
don't
in order to
recommend
get
doing that though, because usually what
0.2275
happens is people
it's
accidentally make
1
mistakes and they get
minus
numbers like
this
0.9.
Oh,
And they
okay,
multiply
okay. Can I use
0.9 by 2 and they get p-values that are over 1. That's impossible. You never have a p-value over 1. The p-value has to be between what two values? 0 and 1. It's the probability. It has to be between 0 and 1. Here, the probability was 0.0455. So one more time, What's the shortcut? Take 0.02275 and multiply it by 2. But I really want you guys to draw the pictures because the pictures are foolproof. Okay, left tail test. If your z value is -2, and we have a left tail test, what side are the extreme values on? Left. See if we can find the p-value for both the left tail test and also the right tail test. So let's go ahead and do groups of 2.
Yeah, just be, yeah.
Oh, like it's
And for left tail test, we're testing to see if the z value is extreme on the left side. So extreme values are only going to be on the left side.
we have to do the same.
No. Because it's just the
Oh,
left
because
side.
this one was 2 tail.
Yeah, it's just on this side.
Okay,
So the answer is just that. And then the right one is just the 1 minus.
Yeah, because it's, if you do know that this, they still get this. So
Yeah,
one.
but it's just the same answer though, right?
No, it won't be that. It will be like, because it'll be this whole area.
Wait, what are you doing 1 versus?
-2.
Why are you doing positive 2 over here?
Because the positive, this is like the z value you're taking. It's +2.
Why is it -2 if it's on the right?
Because it's only, because like that's the z value we're given, right? We only use +2 if it's 2 tail.
Okay.
So it would be that 0.97.
Oh, so in this case, it's
okay, so these are not 5.
7725.
So these are 2.5%. Yeah, they're all 2.5% because 5% is the total. You have 2.5% on both sides. Okay, I think most of us are doing this right, so let's check our answers. For a right-tailed test, where are the extreme values? Oh wait, I skipped it. I'm supposed to do left tail first. So left tail test extreme values are on the left. So I'm gonna do norm dot s dot dist of what value? -2, comma, true, and that's it. Do I have to add it to anything else? No. That's it. Stop there. Okay, right tail test, where are the extreme values on? On the right side. So in this case, am I going to do norm dot s dist of -2, comma, true? 1 minus, good. And that gives me 0.97725. Okay, questions on how to find the p-values? Okay, we're kind of getting low on time, so we're going to have to kind of go through this a little bit fast. How do we know if we have an extreme value? What are we going to, what tells us whether the p-value is considered extreme? So the critical value was what led to the... Oh yeah, you're right. The critical value. You're correct. It's a critical value, but the critical value is a z-value. We can just jump to the significance level. Where the significance level tells you the percentage of extreme values. So here, you're actually going to look at the significance level. So here we're giving a significance level of 0.01, or that's 1%. Does your answer to question 15 change? Here we said that getting a sample like 8, or sample mean like 8 is 5%, which is low. But is it low enough if you're actually saying the significance level is 1%, meaning only 1% of values are considered extreme? So the significance level is the percentage of values that are extreme. So let's see if we can do question 18. Remember that our p-value was 5%. P-value is 5% from before. Okay, think, pair, share. Significance level 1% just means 1% of values considered extreme. So it only be if it was 1% or lower. So yes, our answer is changing now because we're not considering it extreme.
So yeah, it would change. Because the significance level determines whether it's considered extreme or not. I don't know what it would change to.
Okay, so previously we rejected because we said that 5% was pretty extreme, but now what's considered extreme? Only the top 1%. So is 5% considered extreme if we only if our significance level is 1%? No. Sample mean is no longer considered extreme. And the sample mean was 8. I'm just, you should write something that has to do with this. So usually on the test, you just compare the significance level to the p-value. And if the p-value is blank compared to the significance level, if it's greater than, it's not considered extreme and you fail to reject. If it's smaller, then you reject it if it's smaller. So last chance for me to say that, you reject when the p-value is blank compared to the significance level. Okay, in order to reject it, it has to be less than 1%. But our p-value is greater than 1%. Okay, let's try these two examples now. And we may have to stay a little bit after class, which means there's going to be extra credit involved. Yeah? Okay, I'm coming in just a second. Okay, for number 19, we're going to want to calculate our null and alternative hypothesis like usual. Then you're going to calculate your test stat. And then you want to calculate your p-value. And then you're going to make your decision. Okay, I'm coming. Let's try number 19 in groups of 2. You could just jump right in our groups.
It's more
Because that's the,
I always mix that up.
yeah, that's the competition.
It just is different from 150 pounds. It doesn't say greater than or less than. So would that mean
It's just, it's the, two-tailed, yeah.
okay. So now we do the critical value. What's this again? 0.1.
So,
Tell me the critical value.
Yeah, but we have to calculate we're the same. So we have to do
yeah.
We're setting up our norm.
You don't have the
So this is
We're planning the population is different from
1.98.
So exactly.
Critical value. Well, there's two critical values.
There are two?
Yeah.
What's
It's negative.
oh, it's negative.
Well, that's
Okay.
Well, that's the Z. That's
Well,
Z.
Z and critical value is the same exact thing.
No, so this is the test. What's it called?
No. You have to calculate the test statistic by finding the Z value. Z equals X minus.
Yeah, that's this one.
Oh, you already calculated
Yeah,
that?
I just have it else. So yeah,
Oh,
that's
so
that.
that's.
We don't need the critical value because this is a critical value approach.
The P
What-
either. So P
What is the
value.
P? So what do we have to do instead of that?
I do the norm.
So how do we find the Z value? The Z value is X bar minus mean divided by the
You
standard.
found that. So
Yeah,
that's what we got.
Oh, okay. Oh, that's fine. Then we find the P value by calculating the probability of getting that or more extreme. It's 2 tail, so it would be this case.
So you do norms.
Yeah,
Yes, whatever it is.
Yes, yeah.
Of 1.9.
Yeah.
And then you do norm is this 1 minus 1 minus this.
Yeah.
Of 1.9. Or of wait, is this one negative? And that one's positive? Because we did that and the other one. That's the negative one. And that was, and then they're gonna come out the same value.
So they're both,
And then you multiply them together, or times 2.
yeah, you're right. It is 0.048.
Oh, yeah, and then it's, we have 1 minus 1.
Okay, wait, what is it? Sorry.
0.048.
That's the final answer.
This is the left variance.
Oh, what are the two values?
Wait, you have to.
Yeah, so two different values are 0.024.
So, if we're doing it,
And then that up. Okay.
oh, yes, like,
You just got it.
We have to still say it's like.
We reached it. So what we're comparing is the critical this value, the Z thing, to this. And if it's bigger than that, I think, that means that it's extreme. Because remember, what's considered extreme? 1.98. So it's anything bigger than 1.98 or below negative 1.98. This falls within that.
That's if you find
So this would be
that's
negative.
like if you did a critical value.
A shortcut is
Like, yeah, you know what I'm
Okay, I
saying?
keep forgetting.
Yeah, but the, so the P first was,
Oh,
because you're getting
I'm
the one
confused. How do
minus
we figure
this
out whether it's rejected or not?
value.
What are
What
we
was the
comparing?
P value?
P value is 0.048.
Okay, so that means it's in
So what you're
the
trying
top
to do is find that
4.8% of extreme values,
Right.
but extreme values are only considered 1%.
so you do know. But that's what you meant by like the shortcut. Just do, because this works to the left.
Right. So there's not
So you
enough.
just, every time you get a new value, you're doing the p-value approach.
You don't have to write the whole thing. Don't make me do it that much work.
You've got this.
I'm just worried about the
And then this flip side you did, multiply that by two.
Okay.
So you do like that.
Thank you. All right, let's do that.
Okay, let's go over 19. We're testing to see if the mean is different from 150. When we calculate the z-value, we do x bar minus mean over standard deviation, and so when we do that, we get 182.9 minus 150 over standard deviation is 121.8 over the square root of 54. That gives us 1.98. And now to find the p-value, I'm going to put the 1.98 over here. What does it mean to be more extreme? If it's two-tailed, what side are the extreme values on if it's a two-tailed test? Okay, both. So I need to actually put negative 1.98 on the graph too. So I need to calculate these areas here. I'm going to do, because I had positive 1.98, I'm going to do norm.s dist of positive 1.98 comma true, but that's not going to give me the right area. So how do I find the right area? 1 minus. So 1 minus. When I do that, so equals norm.s dist of 1.98 comma true, and then usually you do not get, when you're calculating p-values, you shouldn't get big numbers. So if you get a big number like that, chances are you're supposed to do 1 minus. So I get 0.024. So that means this side is 0.024. Do I need to really do it again, or can I do what with the 0.2? Multiply it by 2. So this is also going to be, oh no, my top fell off. 0.024. So multiply by 2 to get 0.048. What decision am I going to make? That means the probability of getting this value or more extreme is about 5%. So it's in the top 5% of extreme values. Well, this is significance level. That means only the top 1% are considered extreme. So is this considered extreme if you're 0.048? No, not extreme. Do not extreme, or do not reject, yeah. Not extreme because it's bigger than 0.01. So fail to reject. Okay, any questions on this? Fortunately, we didn't get to number 20.
I'm a twin, you said like, we write our decision to like add something else.
Yeah, I ran out of room, but we're testing to claim that the population mean is different from 150, so we cannot really go with that. Do you guys think we can do p-values for left and right tail tests?
Let's try.
So if it's a right tail test, are you multiplying anything by 2?
No.
No, you just find it on the right side if it's a right tail test. If it's on the left side, p-values on the left. I'll be available for office hours if you need extra help. So you got negative 1.147. It's a left tail test, so you just do norm.s is a negative 1. Exactly. You would have rejected it.